Okay, let's dive deep into the world of 3D printing.
Sounds good.
We'll be looking at the patent that kind of started it all, Charles W. Hall's 1986 patent,
Right.
uh, apparatus for production of three-dimensional objects by stereolithography, it's called.
Yeah. And it's not just some old document.
Right.
This patent, it really lays out the blueprint for this whole revolutionary technology.
Yeah, and, we all use 3D printing today,
Hmm.
but we don't always think about, how hard it was to just make a simple prototype back in the early 80s.
Oh, absolutely. Back then, you were stuck with like manual labor,
Yeah.
traditional machining,
Yeah.
each part like painstakingly crafted. It took forever.
And super expensive, too, I bet.
Oh, yeah. And it really held back innovation. You couldn't move fast.
Right. So Hull comes along with this invention, stereolithography, completely changes the game.
Yeah, building objects layer by layer,
Right.
using UV light to cure a liquid photopolymer. Wild.
And the patent, it goes deep into this whole system, a vat of this special liquid,
Right.
exposed to a UV light, which solidifies it, but in a really controlled way.
That's the key. Control.
Right. And that's where the real breakthrough is, right?
Exactly.
Because the patent talks about how precisely they control the UV light source
Mm-hmm.
to form each layer of the object.
And this is where the computer comes in.
Okay, yeah.
Dictates the movement of the light source.
Oh, precise.
Down to the tiniest detail, making sure every layer is perfect.
So you've got this interplay of light, material, and computer control all working together
It's a beautiful thing, really.
to create this three-dimensional object.
Yeah, and to help this whole process, Hall came up with this elevator platform
Okay.
right in the vat. It's like the foundation for the object.
Interesting.
As each layer gets solidified, the platform lowers the whole thing deeper into the vat.
So it just keeps building up.
Exactly. Continuous process.
Yeah.
This was huge for making objects with different heights.
Right. Different levels of complexity.
Exactly.
Okay. So let's dive into the liquid itself, the photopolymer,
All right.
the patent. It talks about all these key characteristics.
It had to cure quickly.
Oh, yeah. Why is that?
Well, if the liquid didn't solidify fast enough when exposed to the UV light,
Right.
the layers would just lose their shape. It'd be a mess.
It had to be adhesive too, right?
Oh, absolutely. Each new layer had to stick to the one beneath it.
Yeah, to create a solid structure.
A cohesive whole.
So what about viscosity?
Yeah, Hull knew that had to be low.
Oh, okay. Why?
So the liquid could flow smoothly, creating an even coating for each new layer.
Makes sense.
No defects in the final object.
And even post-processing was considered.
Oh, yeah, Hull was thinking ahead.
He mentioned the solidified object would need to be cleaned.
Get rid of any uncured liquid. It shows his attention to detail.
Right, like he's thinking about the whole process from start to finish.
Absolutely. And he even names a specific material in the patent.
Okay, what is it?
Loctite Corporation's potting compound 363.
Ah.
That's what he used for his early prototype.
So he's grounding these theoretical concepts in real-world materials.
Exactly. Testing it out, making sure it works.
He was very thorough.
Oh, yeah. And the light source, that was important too.
I bet. What did he use?
A 350-watt mercury short arc lamp.
Okay.
Focused through a fiber optic bundle.
Interesting.
This wasn't just any old lamp.
Right.
Focusing the light, it created a small, super intense spot of UV light.
Really precise.
Exactly. Perfect for curing the liquid.
So you have this tiny beam of light tracing each layer.
Building it up with amazing accuracy.
And to make it even more precise, he mounted the light source on a digital plotter.
Yeah, controlled by the computer.
So it could move with incredible accuracy.
Yeah. This was key to realizing Hull's vision.
Of automated 3D object creation.
Exactly.
But he didn't just stop there. He was already thinking about other possibilities.
Oh, yeah, he had all these variations and alternatives in the patent, always innovating.
Like what?
Well, for example, he thought about using a heavier transparent liquid
Okay.
beneath the curable liquid.
Yeah.
This would let the object be pulled upwards as new layers were added.
Instead of being lowered down.
Right. Different way to achieve the same result.
Interesting.
Different mechanical implementation.
So he was already thinking about different ways to approach this.
Oh, yeah.
Yeah.
And he also considered using a collimated UV light source with a patterned mask.
What would that do?
Create objects with a constant cross-section.
Huh. So more like an extrusion process.
Exactly.
It's amazing how he was exploring these different avenues even at that early stage.
It really shows his thoroughness, his willingness to consider all the possibilities.
Yeah, he wasn't content with just one solution.
He wanted to find the best way to achieve his goal.
And that, I think, is what led to the widespread adoption and evolution of 3D printing.
Absolutely. His forward-thinking approach is all over the patent.
And it paved the way for all the amazing things that 3D printing can do today.
It's a reminder that innovation, it never stops.
It's a continuous process.
Yeah, always refining, always exploring.
Now let's go back to that specific material he mentioned.
Okay.
Loctite Corporation's potting compound 363.
Yeah, it's a small detail, but it's really interesting.
What do you mean?
Well, it shows that Hull wasn't just theorizing.
Right.
He was actually experimenting with real-world materials.
So it was more than just a thought experiment.
Exactly. He was testing it out, making it real.
And that's crucial for understanding the impact of his work.
Absolutely. It bridged the gap between theory and practice.
And paved the way for the development of actual 3D printing systems.
It's a testament to his pragmatic approach.
He wasn't just a dreamer, he was a doer.
Yeah, he had a vision, but he also knew how to make it a reality.
Now, what about the light source?
The mercury short arc lamp.
Yeah, why that one?
It might seem obvious now, but back then, it was a really smart choice.
How so?
Lasers were still pretty new and expensive in the 80s.
Right.
Hull realized that a mercury short arc lamp, it was powerful, it was readily available.
Practical.
Exactly. It let him build a working prototype without breaking the bank.
And by focusing it through the fiber optic bundle.
He got the intensity and precision he needed.
Clever.
It was a brilliant solution, leveraging existing tech in a new way.
It reminds me that sometimes the most groundbreaking inventions
Yeah.
aren't based on entirely new technologies.
Right. It's about combining existing elements in a clever way.
Exactly.
And Hull was a master of that.
And mounting the light source on the digital plotter.
Oh, that was crucial for automation.
Tell me more about that.
Well, by connecting it to a computer-controlled plotter,
Yeah.
he achieved a level of precision that wouldn't have been possible by hand.
Right, because the plotter could move the light in these intricate patterns.
Following the digital design perfectly.
It's like the birth of computer-aided manufacturing, or CAM.
Exactly. Hull's patent laid the groundwork for integrating computers into manufacturing.
Which has revolutionized the entire industry.
It's amazing to think that this fundamental concept was already present in those early days.
And it all goes back to Hull's vision.
Of a future where computers would design and fabricate physical objects.
And his patent was a major step towards making that vision a reality.
Absolutely.
Now let's talk about some of the alternative approaches that Hull explored.
Oh yeah, he was always thinking outside the box.
The patent describes all these different embodiments.
Showing his willingness to explore every option.
Like, for example, using a heavier transparent liquid below the curable liquid.
Right, so the object could be pulled upwards instead of downwards.
A different mechanical solution to the same problem.
Exactly. It highlights that there's not always just one right way to do things.
He was open to different paths.
Weighing the pros and cons of each approach.
True innovation requires that kind of flexibility.
Absolutely. You have to be willing to experiment.
And Hull's patent is a great example of that.
He wasn't afraid to try new things.
And that's what allowed 3D printing technology to evolve so rapidly.
It opened the door for others to build upon his foundation.
And to develop new and improved methods.
Hull's vision was expansive.
And his patent reflects that.
He laid the groundwork for an entire field of technological innovation.
Yeah, and another alternative he considered was using a collimated UV light source with a patterned mask.
What would that do?
So that approach would let you create objects with a constant cross-section, you know?
Oh, interesting.
So kind of like an extrusion process.
Right.
It's really remarkable how Hull was exploring all these different avenues, you know?
Yeah.
Even in those early stages of development.
It speaks to his thoroughness as an inventor.
Yeah.
His willingness to consider different possibilities.
Yeah, and it's clear from the patent that he wasn't content with just outlining one solution.
He was already envisioning ways to, refine and adapt his invention for different applications.
And that dedication to exploration and improvement, that's what led to 3D printing becoming so widespread, right?
Yeah, absolutely. It's a reminder that innovation isn't just a static endpoint.
Yeah.
It's this continuous process of refinement and exploration.
Now let's talk about another alternative embodiment described in the patent,
Okay.
using a cathode ray tube.
A CRT,
Yeah,
to project the curing pattern onto the liquid surface.
that's pretty innovative for the time, right?
Oh, yeah, definitely. Back
Yeah.
then, CRTs were mostly known for, like, TVs.
Right.
But Hull, he saw beyond that.
He saw the potential for using them in 3D printing.
Exactly. He realized that a CRT could generate these controlled patterns of light.
Interesting.
And by adapting this technology for stereolithography, he figured out a way to create complex 3D shapes.
With a high degree of precision.
Exactly. So imagine using a CRT to project a precise pattern of UV light onto the liquid. This would solidify the liquid in just the right shape.
Creating a detailed layer of the object.
Right. And by repeating this process with different patterns
Yeah.
and carefully controlling the movement of the CRT, you could build up intricate 3D structures.
That's amazing.
It shows how Hull could see beyond the conventional uses of technology.
Right.
He wasn't limited by what everyone else was doing.
He saw the potential for something new.
Exactly. And this willingness to adapt and repurpose existing technology, that's a hallmark of inventive thinking.
And Hull's patent, it's full of these creative and resourceful solutions.
Absolutely. So by exploring these alternative embodiments, Hull was essentially mapping out the potential landscape of 3D printing technology.
Okay.
He was identifying the key variables, the things that could be manipulated to achieve different outcomes.
I see.
And this laid the groundwork for the diversification of 3D printing techniques that we see today.
Right, because it allowed other inventors to come along and build upon his foundation.
Exactly. They could develop specialized methods for different applications.
It's really a testament to the enduring power of Hull's original vision. Now, let's talk about the emphasis on computer control throughout the patent.
Yeah, that's a key element of Hull's invention.
He really highlights the importance of using a computer to control various aspects of the process.
And it shows his understanding of the future of manufacturing.
Right, because back then, computers were still relatively new.
Oh, yeah, and expensive.
But Hull saw their potential.
He knew they could revolutionize the way we design and create objects.
Because computers could handle all those complex calculations.
Right.
And the precise movements required for 3D printing.
He envisioned a future where computers would be an integral part of the whole manufacturing process.
And his patent laid the foundation for that.
Yeah, it's almost like a blueprint for computer-aided manufacturing.
And that's a trend that has completely transformed the industry.
Absolutely.
So how did this vision manifest in the specific details of the patent?
Well, he talks about using a computer to control the movement of the UV light source, making sure it follows the digital design perfectly.
Right.
That kind of precision wouldn't have been possible by hand.
And it allowed for the creation of much more complex shapes.
Exactly.
And he also envisioned using a computer to control the movement of the elevator platform.
Right, to ensure each layer is built at the correct height,
Automating the process,
eliminating the need for manual adjustments.
making the whole thing much more efficient and reliable.
Exactly.
So Hull's vision of computer control, it really permeated every aspect of his invention.
It wasn't just an afterthought.
It was a fundamental principle.
That guided the entire design of his 3D printing system.
And it's a testament to his foresight.
Yeah, he understood the transformative power of computers in manufacturing.
Now let's delve into another key aspect of Hull's patent, his meticulous attention to detail.
It's amazing the level of detail he provides throughout the document.
Yeah, he gives very specific specs for all the components.
Like the vat dimensions, the power of the UV light source.
He even talks about the viscosity of the liquid photopolymer.
Right, and all these other technical details.
It might seem like a lot at first, but it serves an important purpose.
It ensures that anyone skilled in the art could actually replicate his invention.
Build a working 3D printing system based on his design.
Exactly, so it wasn't just a theory.
It was a practical blueprint.
Guide to actually building this thing.
And that level of detail was crucial to making it work.
It shows the difference between having a great idea and actually executing on it.
And Hull's patent is proof that he had both.
He was both a visionary and a meticulous engineer.
And that combination is what led to this revolution in manufacturing.
Absolutely. Now, let's talk about another interesting aspect of the patent.
Okay.
Hull's exploration of the relationship between light and material.
Yeah, throughout the document, he demonstrates a deep understanding of how UV light interacts with the liquid photopolymers.
He explains how different wavelengths of light can actually cause the liquid to solidify at different rates.
Really?
Yeah, and he describes how the intensity of the light affects the depth of curing.
Fascinating.
He even explores using patterned masks to create specific shapes within the solidified material.
It seems like he was really fascinated by the science behind his invention.
Oh, yeah, he wasn't content with just observing that UV light could solidify the liquid.
Right.
He wanted to understand the underlying mechanisms.
To figure out how to control it.
Exactly, to harness it to his advantage.
And his patent shows a real appreciation for the interplay between light and matter.
Absolutely. And it's clear that this understanding informed his practical decisions.
Like how?
Well, he was very careful in choosing a UV light source that emitted the optimal wavelength for curing the specific photopolymer he was using.
Makes sense.
And he designed a focusing system that concentrated the light into a tiny beam.
To maximize its curing power.
Exactly. And he even experimented with different exposure times.
To figure out the best balance between curing speed and depth.
It's like he was conducting a scientific experiment alongside building this machine.
So his patent is a record of both his engineering ingenuity and his scientific curiosity.
Right, and it laid the groundwork for the development of so many light-based manufacturing techniques.
Like what?
Oh, everything from laser cutting to photolithography.
And of course, 3D printing itself.
Exactly. Light has become an essential tool in modern manufacturing.
And Hull's pioneering work played a huge role in that.
His patent opened up this new frontier of scientific exploration.
It's amazing to think that all of this stems from his initial curiosity.
Yeah, it shows the power of asking questions and delving deeper into the mysteries of the physical world.
Now let's talk about Hull's approach to problem solving.
Okay.
Throughout the patent, he anticipates potential challenges.
And he comes up with solutions before they even arise.
He's thinking ahead.
He identifies several potential issues that could pop up during the printing process.
Like what?
Well, for instance, he realized that the solidified object could get stuck inside the vat of liquid.
Oh yeah, that would be a problem.
So he proposed using a release layer to make it easier to separate the object from the vat.
That's smart.
And he also anticipated that air bubbles could form in the liquid.
Which would mess up the curing process.
Exactly. So he suggested using a degassing system to get rid of any trapped air.
He thought of everything.
And he even recognized that the intense UV light could damage the photopolymer over time.
Oh, right.
So to protect it, he proposed using a protective window.
Wow, he was really thorough.
Yeah, it shows how meticulous he was as an inventor.
He wasn't just describing his invention, he was thinking about all the things that could go wrong.
And figuring out ways to prevent them.
That's a hallmark of a truly great engineer.
Absolutely. It's that proactive approach that leads to successful innovation.
Because in the real world, things don't always go according to plan.
Right. You have to anticipate problems and come up with solutions.
And Hull's patent is a great example of that.
It shows how important it is to be both creative and practical.
To be able to think outside the box and to also solve real-world problems.
And that's why his invention had such a lasting impact.
So as we wrap up our deep dive into Charles Hull's 1986 patent,
It's clear that this document was so much more than just a technical specification.
it was a window into the mind of a true visionary.
A roadmap for the future of manufacturing.
Hull's invention, stereolithography, it didn't just introduce a new technology.
It changed the way we think about design and creation.
And his patent captures that beautifully.
It's a reminder that innovation often starts with a simple question.
What if?
And that with enough curiosity and determination, those what-ifs can transform the world.
So the next time you see a 3D printer in action,
Take a moment to appreciate the ingenuity and the vision that made it possible.
thanks for joining us on this deep dive.
It's been a pleasure.